Lesson 8.8, Areas of Rectangles with Fractional Side Lengths. The focus of this lesson is for you to approximate the area of a rectangle, for you to multiply fractions by whole numbers, and for you to multiply mixed numbers by whole numbers. And in the end, I hope you can multiply fractions by whole numbers. But let's go ahead and start with our mental math and fluency first. 1/2 plus 2/100. Remember that we want like denominators whenever we're adding. So 10 becomes 100 by timesing it by 10, which just means that I added a 0 because 10 times 10 is 100. So 1 times 10 is 10. Whatever I do to the denominator, I do to the numerator. Now that I have hundredths and both of them are hundredths, I can simply add the numerators. 10 plus 2 is 12. So 12 hundredths is my answer. Again, next, how can 10 become 100? I multiply by 10, so 10 times 10 is 100. So 2 times 10 is 20. Again, notice what I did. I made sure whatever I did to the denominator, I did to the numerator. Now that I have both of them as hundredths, I can add the numerators. So 20 plus 10 is 30 hundredths. And finally, again, you should notice that if I add a 0 to the bottom, I add a 0 to the top through multiplication, and 30 plus 20 is 50. Super important that through the summer you are studying your multiplication facts. Between what two whole numbers does the area measure of rectangle A, B, C, D lie? Between what two whole numbers does the area, look at the word area. What do we do for area? What's its formula? It's base times height equals area. So you are taking 4 times 7/8 to get your answer. Well, remember how we do this is 4 times 7 is 28. My denominator stays the same, 8. Now I want to switch that to a mixed number, so 28 divided by 8, it goes 3 times. That gives me 24, and 28 minus 24 is 4. So 3 and 4/8. So between what two whole numbers does my answer lie? It lies between 3 and 4. Because if it was on a number line, and this was the number 3, and this is the number 4, 3 and 4/8 would be equivalent to 3 1/2. That's where this would go on that number line. So let's look at Math Journal, page 295. Read it to yourself as I read it out loud. It says, this is a rough floor plan of Katrina's bedroom. So take a look at all the numbers that we have here. And notice when you're looking here, they're either talking about windows. That's where windows are located in the room. And this is showing you that this is a doorway entering the room. Architects use these symbols to show where the windows and doors are. So the walls of Katrina's bedroom are blue. She would like to paint a yellow border on each wall. It will be 1 3/4 feet wide and will be painted horizontally along the middle of the walls. The border will not cover the door or the windows. A quart of paint covers about 87 square feet. Will 1 quart of paint be enough for Katrina's border? Well, remember, a border is kind of like our number line on the wall, if the number line went all the way around the wall. So it's not going to cover the total surface of that wall. So to find the length of the border on each wall, I need to look at the lengths. So this length is 15 feet. Okay? And this length is 6 plus 3 is 9, 10, 11. This length is 12. But it said that I am not going to do the windows. So actually this side is a total of 9. This is 9. Again, we're not adding where the window is. So 9 plus 3, this side is 12. And we of course wouldn't be putting it over the door. So this side would simply be 9. Do this in your book, because as I scroll down to walk you through how to do this, you're not going to be able to see this on my screen anymore. So I am going to start right here, and I'm going to explain what I just did there. And here I go. So I have 15 feet. And then I have the 12 minus 3 to get the 9 feet that I just showed you, that is to the right of the 15-foot line. Then again, I have the bottom line, which was 15 feet minus 3 feet, and that's how I got the 12 feet, which is that underneath the 15-foot. Now I am going to go back up to that so you make sure I know. I just explained this number and the length of this wall. And then next, I'm going to take 12 minus the 3 foot that we said was the door, which equals 9 feet. Notice how important it is that I am accurate with my subtracting to make sure I can do this correctly. So now I'm going to multiply the length of the border, which they said is 1 3/4, to find the number of square feet. So I take it by the first one, 15 times 1 3/4. So first I'm going to do 15 times 1, which is 15. And then I'm going to do 15 times 3, which is 45. And my denominator stays the same, fourths. So I have 15 3/4. But I need to remember that when, 45 fourths. Now I need to convert that, because 45 divided by 4 would be 11, because 11 times 4 is 44. I'd have 45 minus 44 is 1. So I actually have 11 1/4. How did I get this number? All I did was divide this fraction. Now I need to add this converted mixed number to the 15 to make sure I have the right amount of border length. And it should be 26 1/4. That's just this wall, the first wall. Now I need to do the next one. I'm doing this times 9. Well, luckily, if I look, I have 2 of those. So I can do it once, 9 times, and again my border is 1 3/4. Sorry for my numbers, but you should be writing this down and doing it along with me. I multiply the whole numbers first. 9 times 1 is 9. Then I multiply the 9 times 3, which is 27. And I leave my denominator the same, fourths. Now again, because my numerator is larger than my denominator, I'm going to need to divide. 27 divided by 4 is 6. 6 times 4 is 24. So 27 minus 24 is 3. So when I converted the 27/4, I came up with 6 3/4. I need to still add that on to my original whole number, which was 9. So I'm finding out that this number is 15 3/4. But remember, I have 2 walls that will need that. So I'm actually going to need to add 15 3/4 twice. That comes up with 30 6/4. 15 and 15 is 30. 3 plus 3 is 6. Here again, my numerator is larger than my denominator. So I'm going to go 6 divided by 4 equals 1. 6 minus 4 is 2. So that equals 1 2/4. I need to add that on to my 30. I converted this, so I'm not adding it to this. So it is 31 2/4. So far, I have 26 1/4. I'm going to need to add these, that's why I'm putting it here. plus 31 2/4. Looks how nice this is turning out to be because I have the same denominators. And I have one more I have to do, and that's this one. So I did the 15 right here. I did these two. So I know all I have left is this one. So I'm taking 15. I'm sorry, that number's 12. 12 times 1 3/4. So I do my whole numbers first. 12 times 1 is 12. 12 times 3 is 36. And my denominator stays the same, 4ths. As you can see, the numerator is larger than the denominator, so I'm going to divide that out. 36 divided by 4 works out wonderfully to just be 9. So 9 plus 12 equals 21. So there are my totals. So in order to figure out all 4 walls, I would add these together. 1/4 plus 2/4 is 3/4. 6, 7, 8, and 3, 4, 5, 6, 7. So a quart of paint covers 87 square feet. I only needed to cover 78 square feet. So do I have enough? The answer is yes. Now you're going to open your math journal to page 296. This is the ACI for this lesson, the assessment check-in. It's asking you to find the area of the rectangle. Remember, P is perimeter. Area means that we are multiplying. You need to do that for problems 1, 2, 3, and 4. And then on the very bottom, it's actually making sure that you find the rectangle with the unknown side. So they're challenging you a little bit more. Pause the recording now, do Math Journal page 296, and bring it up to me so I can check off your ACI. Once I've checked off your ACIs, you should go to Math Journal page 297 and do the math boxes. Math box 1 simply having you multiply. The same thing for math box 2, but be sure to show me how you got your answer. Math box 3 says, 6 airplanes left Boston with 685 passengers each. 6 and 685 passengers each. 4 planes left Miami with 732 passengers each. 8 planes left LA with 250 passengers each. Which of the following are true? 1,282 more passengers left Boston than Miami. 13,758 passengers were on these 18 airplanes. 1,620 more passengers left LA than Boston. All of the above or none of the above? So of course, you should know you're going to be doing something with this number with this number. You're going to be doing something with 4 and 732 and something with 8 and 715. Be sure to get out a separate sheet of paper and show your work, because if you got it wrong, I'm going to want to see where you are misunderstanding something. Math box 4 says 4 swimmers on a relay team, each swam a lap in the times listed here. 26 and 27 hundredths, 30 and 36 hundredths, 32 and 15 hundredths, and 26 and 75 hundredths seconds. What was their total time for the race? So show your number model with answer in seconds. B, if they had each completed their lap in the fastest swimmer's time, how long would it have taken to finish? Again, your number model with your answer. And 5 says, the jeweler sold each of the following ring sizes last week. Plot the ring size data on the line plot. Finish page 297, go up to the answer key and correct it, and then turn the recording on for your final instruction. The last thing you're going to do for lesson 8.8 is Math Masters page 330. So please go get that out of the file folder. It says, the Murphy family bought 2 rectangular dog beds for their pets. Fluffy's bed was 3 feet by 1 and 9/12 feet, and Pete's bed was 4 feet by 2 and 4/12 feet. How much more area does Pete's bed have than Fluffy's? And what is the perimeter of Pete's bed? Finish this page and bring it up to me, please. Thank you.